is Timothy Lee Grant, and welcome back to another Leet coding video. So let's get started. All right, so yesterday I attempted to do a sliding window. I attempted to do a sliding window problem, but I ended up failing. So I'm gonna kind of go and try to do another sliding window. Let's try to see if we can do another one. Get some practice. So what's a good one that we want to try? That one's locked. We can't do it. Darn. All right. Defuse the bomb. Okay. So 1652. Defuse the bomb. You have a bomb to defuse. All right. And your time is running out. Oh no. Your informer will provide you with a circular array code. Oh, what's kind of funny is I've forgotten a lot of those ideas that I learned, whatever, like 3 years ago when I was taking this class or that class. But whenever you hear those keywords of a topic which you found particularly difficult in one of your classes, whatever class it was, whenever you just hear that keyword, it just triggers a instinctual, just like feeling. I just got that when I heard circular array. What are the other ones? I feel like there's a lot in my electrical engineering. I can't think of it. But someone said something a few months ago, and it gave me the exact same feeling. I was like, oh. I forget what it was. It wasn't Laplacian transforms. I liked those. Those were fun. But there was, can't remember. Maybe it'll come to me while we're doing this video. Sometimes that happens. But anyways, I just got shivers when I heard this circular array. Oh no. Let's see if it's more difficult than what I remember. Sometimes this also happens. You remember something to be really difficult, and you're like, "Oh my goodness, that was crazy. That was so difficult." And then you come back to it, like whatever, 2 months later, 5 months later, a year later. In this case, I think it's like 3 years later, and then you're like, "Wait, why was I all worked up about this idea?" Right? Like that happens a lot. So let's see about this. All right. To decrypt the code, you must replace every number. Okay? All the numbers are replaced simultaneously. Okay? So I have a code of length n and a key k. Okay? If k is larger than 0, replace the ith number with the sum of the next k numbers. Okay? If k is less than 0, replace the ith number with the sum of the previous k numbers. Okay? If k equals 0, replace the ith number with 0. Okay. As code is circular, the next element of the last element in code, so the last element -1 is going to be 0, and the previous element, so code of n, which is outside the bounds of the array normally, just loops back around to the beginning, and the element before the 0th, which would normally be -1, so you can index like -1 is normally outside the bounds of the array, but in this case, because it's circular, it is the last element in code. Given the circular array code and an integer key k, return the decrypted code to defuse the bomb. Awesome. Do I have any? I have some water left. All right. So code is 5714. K is 3. And now I'm going to go through. Right now I'm just kind of talking myself through, trying to figure out, okay, what is the problem? I read the statement of what we have to do. Now I'm trying to actually put it into practice. So 5 is greater than K. So now I need to sum up all of those. Is that right? So 7 plus 4 plus 1. So 7, so that's 13, 14, right? 7, 8, 9, 10, 11, 12. It's 12. So 12 is there. And now 7 is greater than 3, so I need to sum up those two. This is 5. Oh, but then I do 5 here, okay, which is 10. Now 1 is less than K, which then what do I do? If K, no. If K is greater than 0, replace the ith number with the sum. Oh, so it's just K is greater than 0. So I need to keep summing them up, right? So that's going to be 4 plus 5 plus 7. Okay. Here. And then 4, I need to sum up all of those, which is 13. Okay, so now K equals 0. So now I'm going to replace each of those. When K is equal to 0, replace the ith element with 0. So we're just going to replace each element with 0 because K equals 0. So it's not that we're taking the actual element and seeing if it's greater or less than K. We're just taking, is K positive? Is K equal to 0 or is K negative? So if K is negative, then what do we do here? Replace the ith number with the sum of the previous K numbers. Oh, K gives like how many numbers we're supposed to do? Why did it work for here, right? Like, oh, I see. Because K is 3, so I have here, and then I just take the 3, and then I take 1, 2, 3, I loop back around. Then here I do 1, 2, 3, so I loop back around. Okay. Now, K equals -2, so now I need to look here and replace the ith number with the sum of the previous K numbers. So previous, so I need 3 plus 9, so 12. Awesome. Then 4, so I need 2 plus 3 is 5. Awesome. Then 9 is going to be the 4 plus 2, which is 6, yep. Now 3 is 9 plus 4, which is 13. Awesome. Okay, so I understand the problem now. How do we do it? Obviously, I can think of a path forward for doing a kind of brute force method. Trying to think of how to make it not O of n squared time complexity. And how is that sliding window? So the way that I could do it brute force would be something like this, where I loop through, like, what would that be? Something like 4 element in code, okay? and then for a number in range range of k, right? K. But then I need to figure out, am I going this way or going that way, I guess. Okay. So now yeah, I this always happens. I say that, oh, the brute force method, that's going to be easy. I'm trying to figure out how to optimize it. And then I just attempt to do the brute force method, and then I just get like stuck. I just hit a wall, and I'm like, oof. Okay, well, it's a little bit more difficult than I had initially thought. But that's okay. Remember, when something is difficult, that means we're learning, okay? That's what we need to remember. That's what we tell ourselves every time we encounter something difficult. We're learning. We are advancing. Okay. So, how am I going to do this brute force? Okay. Well, what? Well, I have this location, which is going to be the element in code. I want the index of the code, right? Like, I don't know. For index for element in range length of code. So now I'm just going to do lang code equals length of code. Let me just put that in there. Len code. Okay. Whoops. Okay, so this is going to give me an index because I'm doing a range function. So it's no longer giving me the actual value like 5, 7, 1, 4. It's giving me the index. Okay. Now, I need to determine if k is positive or negative. So if k is greater than 0, pass if k is equal to 0, pass if k is less than 0, pass. Okay, so I'm doing something for each of the k's based on if they're positive or negative. Okay. Let's only focus on this right now. We're going to look at the other ones later. Okay. If k is greater than 0, what do we want to do? We're going to be at a it's a train. We're going to be at a specific index. Okay. Now, I want to replace this number. So I know that I'm going to have to have a new array. So new array or answer is going to be equal to an empty list, and we're going to append to that list. Okay. So now if k is greater than 0, we're going to element is going to be a specific index, and we want to go through how many times? We want to go through k times. So for number in range. Okay. So now number is going to give the index which we want, or which we're going to add. So we're here at 5, and we want to add this one, and then this one, and then this one. So k is going to be 3. So we're going to start at 0, which would normally add this element, right? So, but we actually want to add this element. So we want our current index plus k, or sorry, plus number, which is the index of the k, plus 1, because we want to move over. So let me just write that. Current index is equal to number plus element plus 1. Okay. And now I know that because we're doing like the circular thing, we're going to need to use that modulo operator, which I think, to be honest, I think this was a thing that I really hated in I hated using the modulo operator. The way that the way that it clicked in my head after struggling with it for a little while was kind of like a clock. So this is the like hours. No, this is the number of hours on the clock, right? So normally there's 12 on a clock. Now, this is the number, like how many hours have passed. Let's say that 20 hours have passed. So on a clock, which has 12, so right here it has 12, you're going to start at 0, you're going to go 12, and then it's going to reset back to 0, right? Because the next one, once you hit 13, you're actually at hour 1 again, right? On a clock. So for 20 hours, you have 12, and then you hit, once you hit the 12, then 13 is now 1, okay? So 13, 14, 15, 16, 17, 18, 19, 20. So it's 8, right? Just like a clock. So that's kind of how it clicked with me. I'm still not like fully comfortable with all of that, right? Like it still takes my brain like, wait, hold on a second. What's going on here? But that's kind of how I thought about it, and it made a lot more sense. But I remember that this initially was kind of scary for me when I was learning programming and stuff. So, okay, so current index, that is the one that we want to add. So, we want to do like a partial sum, right? Partial sum is equal to 0. So we're starting at 0, and then we are going to partial sum plus equals, so we're going to add to it code at our current index. So I think what this is going to do is so we're looking at this 5, which is the first element, and I'm going to go 3. So I first start where it's 0. So this number is now going to be 0. So I do 0 plus element, which is also 0, plus 1, modded by the length of this array, which that means it's going to come here, then come here, then come here, then come here, and then come back to 0. See? But that's not going to trigger anything because remember, on a clock, if you go 2 hours, well, it didn't change anything because it didn't loop back around. So we didn't loop back around yet, okay? And now I'm indexing this code at 1 because I said current index is now equal to 1. So number is 0, element is 0, then plus 1, and we're not looping. So it's 1 here. So now we're looking at this 7, and we're adding the 7. Then the next one, we are going to have number, or sorry, element, I should say. Element here is still this 0. It's the 5. That's our element that we're caring about. Then number now is the next one in the K, which is 1. So 1 plus 1 is 2. So now we're going to be adding this 1. It's because it's the second index in the code. So we're adding that to partial sum. So now we have 7 plus 1. So we have 8. And then we're going to do the exact same thing for this 4. We're going to add that to partial sum. And then once this has completed, we are going to store that in the element location of our new code. So answer.append partial sum, and we can do the append because initially it's an empty list, and so we're going to put in the first element, okay, and then we're going to put in the second element, and then we're going to put in the third element and fourth element and fifth element, however many elements there are. So that's why we can do the append, and we don't need to like have this fill it out with like zeros or something like that initially. So we can just keep appending to this empty list, and that will correspond to the first element and then the second element and then the third element. So it will match this index value is what I'm saying. Okay. Maybe it's good. I don't know. We won't know until we press that submit button. Let's do this k equals 0. So in this case, we want to just replace all of the numbers in our answer with 0. So for blank in range, what? Okay, this one will just be answer.append and then 0. So we're just appending 0 to our answer, and we're doing that for each element. So it's going to be 0, 0, 0, 0. Okay, so now this one we also need the partial sum is going to initially be 0, and now we are doing what? We are adding the sum of the kth previous. So we're going in the opposite direction. Okay, we're going in the opposite direction and adding k values of those. So for number in range of negative k. Remember, we don't want to put in a negative number here. We want k to be positive. So range should be positive, right? So we're gonna get like 0, 1, 2, 3, 4, 5. Let's just say that this was negative 3. So we're gonna get 0. So we actually want to go back 1. So instead of this plus 1, we're gonna get negative 1. So how do I want to do that? So current index equals what? Where I currently am, which is element, and now I'm going in the opposite direction. So instead of plus, I'm going minus number. Okay, and then I want to do the minus 1 because I don't want like this one plus 0 or minus 0 and use this element. I want to pop over here and get this one. Okay. So now, partial sum plus equals code. So I'm indexing the code, and then I'm getting current index. Okay. At the current index, and then I am going to do the same thing. Answer dot append partial sum. Okay. And then once this for loop finishes, I am going to return the answer. Do we want to press submit? Let's see if it hits. What's your confidence level? I'm curious. What's your confidence level in this answer? I'm not sure. I'm at maybe I guess I would split this into two questions. What's my confidence level in all of my syntax, in all of the implementation? I'm gonna say about a 20%. Okay. I'm gonna give myself a 30%. Okay. Then what's my confidence in the general implementation? I'm gonna say about a 70%. Okay. So those are my associated confidence levels. Let's press the submit button and see. Come on. Yeah! Yes! 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 Brute force method. We got it. Okay. Yo, okay. Let's go. Oh, yeah. Okay, it's obviously, it's not here. It's not the optimal solution. But but fundamentally, I was trying to challenge myself. Like, okay, I couldn't initially immediately, bam, quickly code up a brute force method of solving this, right? As I said at the beginning of this video, like, okay, I'm struggling. That means I'm learning. And I was able to get the brute force method, which that's why I'm so happy about that, right? Now let's take it to GPT and let's figure out what the optimum solution for this is, and that way we get both contexts. We get the practice of solving it, we get the practice of becoming a better programmer with, okay, I have a general idea, I need to implement that in code. How do I do this, right? Then now we're going to go to GPT and figure out, okay, what is the optimal way of doing this? What's a clever method? How do we do this? Okay, so let's come here. Here is my solution to the question. Should we just copy and paste all this? Yeah. Usually it knows it anyways. All I need is the title, but can you tell me more optimal solutions? All right. Okay, so sliding window. Yeah, we didn't use a sliding window, and that's something I was like, okay, so instead of recalculating a sum for each element, you can use a sliding window approach to maintain the sum of the next previous k elements. So that's actually, if you remember, that's kind of what we pressed on. Like, that was the topic which we said that we were going to be looking at, is sliding windows, and we didn't use that, obviously. So this reduces the time complexity from n times k, right? And so worst case scenario, k is, oh, k actually, it wouldn't be n squared because k could be really large, right? So yeah, absolute value of k, because k could be a huge negative number, right? Like negative 1 trillion, something like that. And so you would have to go through, for each element in the n, you would have to go through 1 trillion times. So it's each element times how many times you need to do it. And then we're taking that all the way down to O of n. Okay, so here's how you can implement the sliding window technique. So for k equals 0, initialize the sum of the first k elements. Okay? For k equals 0, initialize the sum for the last k elements. Update the window sum. As you move the window, update the sum by subtracting the element that is left behind and adding the new element that comes into the window. Okay? Oh, the other thing that I just realized was, so remember when I said at the beginning of the video how I got freaked out by this circular array, and when I was initially learning it, I was just like, this is so confusing. I how is this working? I kept getting, this is outside the bounds of the array. That's outside the bounds of the array. What's going on? And it just it 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 I hated that idea. Look, we were able to implement it, and I didn't even really think about it. It's just like, oh yeah, that's how it's gonna work. You take the number of ticks that you're doing, and you mod it by what? The number of ticks. Which what is the number of ticks? It's the number of elements in the array. So the reason that I want to point this out is because if you are experiencing something which you find very difficult, just keep at it, just keep learning, and eventually it's going to be something which you don't even worry about. So I just want to point that out because I think it's really helpful to show people, like, hey, a concept that you find really difficult today, two weeks from now, 2 months from now, whatever it is, right? Like it might be something which is mundane to you sometime in the future, right? I haven't touched a circular array since data structures, which was a sophomore level class 3 years ago. Was it 3 years? I can't remember. Anyways, maybe 4 years ago. Now that, because uh, I've been working. I am out of college for over a year now. Hey, and now it's February 1st. So it's actually now it's 1 year and 2 months. So now that February just hit, I got another an extra month of work experience. So I've been out of school for uh what was it, 6 months, and I was applying for jobs, and then I got my job in December, and now it is December of last year, right? Did all of that year. Now it's January and or February now. So, anyways, I have not touched circular arrays. I have not looked at circular arrays. I have not studied circular arrays in at least 3 years. And I remember the last time I looked at it, I didn't like them. I was scared of them. I was confused by them, and I never conquered it, right? That's what I'm trying to say is I never conquered this topic. And as you saw in the beginning of the video, I legitimately kind of like got scared when I saw that word. I was like, "Oh no. Okay. I remember I really did not like this." But even though I haven't looked at it, I haven't studied it, I haven't done that, right? Like I was able to get it now. And I think that the reason is because, well, I learned other topics. I became a better engineer. I became better at programming. I learned more about this modulo operator. Right, like, I learned all of this background stuff. And so then when I went to go look at this concept again 3 years later, it didn't even need to be something in my brain. I just wrote it out. So I just want to give this kind of word of encouragement to people. Like, if you're struggling with a topic and you find this topic really difficult, um, like, don't be too concerned about it. Like, try to conquer it, right? Obviously, I think doing your direct attacks, trying to learn it as fast as possible, as efficiently as possible, like doing those direct attacks, obviously, great. But don't get disheartened and don't be like, oh, I'll never be able to learn it, because even if you don't even like, you can. And so don't get discouraged on that. Where was I? Back to here. Okay, so update the window sum. As you move the window, update the sum by subtracting the element that is left behind and adding the new element that comes into the window. Okay, so we have this decrypt. We come here. If k is 0, we just return a 0 list, which is the size of n. Awesome. Okay, if k is equal or is greater than 0, okay, we loop through from 1 to k plus 1. Why are we doing that? Starting at 1, going to k plus 1. Okay. So we're just doing k elements. Awesome. Window sum plus equals. So we're just going through k elements. Okay. Now, and this is going to evaluate to a specific value. Yeah. A specific integer, I mean. For I in range in. Oh, but actually, I'll say this later. Let's focus on this, and then I had one more thing to say about the circular arrays. I'm full of that today. So for I in range n. So what are we doing here? We're taking this integer value and we're storing it at the result of I, and then plus equals, we're changing the window sum. Oh, so I think the thing that we can do is I think what's going on is we're looping through here and then here and then here. However, like if k is really large, right? So we're initially here, but then we add all of those, and then we loop back and add here, and then loop back and add here, and then loop back and add here, and that's what is the window sum, right? That's what window sum is. We do that k times, okay? Then here, I add window sum to the result. So I put that window sum in the slot. So now I'm going through each slot in the element. But then I change window sum. I increase the value by what? By code, which is this. So I is the current index plus k plus 1 mod. So what's that gonna do? That's going to, I think that has to do with like if I'm here, I need to take out this value, right? I think that's what it means. Yeah, so I think what we need to do is, well, because we start, oh, I see. So we're adding all of these however many times k times, right? But then what we need to do is we need to, if we're at this element, we need to remove this 5 and then add all of those k values and then plus one extra of the k value. And then once we get to this one, we need to remove this 7, but then add back this 5, right? So I think that's what this part is doing. So then it's just going to how I kind of, so right now I kind of see what's going on. I can't fully articulate it. If you asked me, okay, just code it from scratch, I would have a very difficult time, but I see kind of what they're doing. I'm gonna have to think on it. I'm gonna have to convince myself of it, but I kind of see what they're doing. Okay, which is great because that's kind of what I want to do with these series is I'm trying to get a wide variety of different problems. I'm trying to understand as much as I can, let my subconscious see all these problems, get practice doing the problems, and uh, so that was my point of doing these videos, right? Um, the other thing that I wanted to mention with the circular array is it also kind of proves like don't be scared of revisiting those topics which you previously found very difficult. So if you have those topics that you've kind of been avoiding and you know in the back of your head like, oh man, I really struggled with concept X. Well, if it's been a little while, why not revisit X? Because you might not have a difficult time with it anymore. So that's kind of another word of encouragement is if there's something which is kind of causing you stress or something which you're scared of, maybe give it a little bit of a try. If it's been a duration of time, you might find it a lot easier. And if not, well, then just keep practicing other things, maybe tangentially connected. There we go. Like in the area of that concept. And the more you learn in this area, the easier the actual difficult part is going to be. So, I mean, there's a lot of things that you can do to move forward and make progress on those concepts that kind of just throw you. And everyone has those different concepts that they're just like, man, what is going on here? But anyways, thank you guys so much for watching this video. I hope you guys have a wonderful rest of the day. If you liked it, subscribe. That would be amazing. I am almost at 600 subscribers, so thank you to everyone who subscribed. I do one Leetcode video every single day. Keep going, keep going, keep going. Trying to give myself a wide, just do a ton of problems. If that's something which is interesting to you, welcome. If not, that's okay as well. I hope everyone has a wonderful rest of the day. My name is Timothy Lee Grant, and I will see you guys tomorrow with more Leetcode.